Today we will be going to solve this question, search in a rotated sorted array. So this is the question. Given there is an integer array nums sorted in ascending order with distinct values. Prior to being passed to your function, nums is rotated at an unknown pivot index k. For example, 0, 1, 2, 4, 5, 6, 7 was the earlier array, and after rotation at the pivot index 3, which is this one, it becomes 4, 5, 6, 7, 0, 1, 2. Given the array nums after the rotation and an integer target, return the index of the target if it is in nums or -1 if it is not in nums. And the expected time complexity for this question is big O of log n, right? So let's now see the example. So this is given to us, which is a rotated sorted array, and the target element is 0. So 0 is present in this array, and now the output will be 4. That is the index of this element in the array. Let's see the target element as 3, and there is no 3 present in this array, so the output will be -1. Right, so now let's see how we'll be going to solve this question. So earlier the array is sorted, but prior to being passed to our function, it has been rotated around a pivot index. So let's say this was the earlier original array which is sorted, right? And now after being passed to our function, it is being rotated around this pivot index, right? So after being rotated, this 0, 1, 2 is followed after the array, so means it's rotated, right? So now we need to find this we need to find the position of the element in this sorted array, in this rotated sorted array, right? So one solution, a naive solution, can be to simply iterate through whole array, and whenever we find the element, we return its index, and if not, we return -1 at the end, right? The time complexity for this approach will be big O of n, right? But this question expects us to write an algorithm which will find the array, find the element in the big O of log n time, right? So now let's see how we'll be going to solve this. So for example, if this was the original array and we need to find the element in this sorted array, right? So to find the element in the sorted array, we'll use the best algorithm is to use the binary search algorithm, right? Which will help us to find the element in the big O of log n time, right? But now the array is sorted and rotated, which is this one. We'll need to find the element in this sorted array. So we'll be using similar binary search again, but we'll need to do some modification in the original algorithm to find the element, right? So now first of all, as usual in any binary search algorithm, we'll be finding the middle of the element. So in this case, this element is the middle, and we'll check if the middle element is equal to target. If it is equal to target, we'll simply return the position of that middle element, otherwise we'll move forward, right? So now to attain the big O log n time complexity, we need to either go left of this middle element or right of this middle element, right? We need to neglect the half portion of the array, then only we will get the big O of log n time, right? So how will be neglecting the one part of the array and moving to other part, right? So let's see. So in this case, let's say the target element is 0, or let's say the target element I'll be using in this is 5, right? So let's say the target element T is 5, so we need to find the 5 in this sort of rotated and sorted array, right? So if any array is rotated and sorted, it's sorted and rotated either way, so the one part of this array will be in the sorted order and the other part of this array will not be sorted, right? Considering any middle point. So in considering any part of the array, let's say this part of the array, so let's say we deviate this array from this point. So this part is not sorted, but this part is sorted, right? Consider any another position, let's say this. So this part of this left part of this position is not sorted, is sorted indeed, and this part is not sorted, right? So there is always a part either left or right of that middle element or the element from which you are dividing the array, which is sorted, right? So how will we going to check whether the left part is sorted or the right part, right? So let's say this is the middle element 7. We'll check for the leftmost element uh, from the middle element. So leftmost element from the middle element is 4, and we'll check whether the leftmost element is smaller than 4, is smaller than middle element. If that's the case, then we can surely say that the left part is sorted, right? How can we say that? See, the original array was 0 1 2 4 5 6 7, and after rotating it, we have pushed one part of the array to the last, right? So the other part is sorted right now, yeah, and we are only finding that sorted part. So we will just need to check whether the left part is sorted or the right part. So in this case, the leftmost element, which is 4, is less than the middle element, then we can say that left part is sorted, right? And now we'll check in the left sorted part that whether the target element is in the range of 4 and 7, right? So right now the target element is 5 and the range left part is sorted, so we'll go to the left part and check whether the target element is present in this range, because there if the element is to be present, it must be present in this range. It can't be present in this range, right? So we'll check over here. So we can see that 5 is in this range. Then we'll again go to the middle of this sub array, and then it will be going to be this. So now the middle element will be this, and we'll again check whether the middle element is equal to the target. Yes, so it will be equal to target, and we'll simply return the mid position, right? Now let's check for another test target element, which is 2, so you can get a better understanding of this problem. So let's say the target element is 2. So we'll again come to the middle element and check whether the left part is sorted or right part is sorted. So we'll check for, if the leftmost element of the left of the middle is smaller. Yes, it's smaller, and we can say that left part is sorted, right? And now we'll check whether 2 is present in this range or not. See, 2 is not present in this range because 2 is less than 4, right? So we can say that 2 will be not be present in this range, and then we'll move to the right hand part, because will neglect whole this left part and we'll go to the right hand side, right? And now we'll again come to the middle element of this right sub array, this one. Okay, so now we'll check if ARR of mid, which is this one, equal to the target element. No, it is not equal. So now we'll move again to the we'll check for the left hand side and the right hand side, and now we can say that left hand side is sorted. So we'll move to the left hand side and check whether target is in this range of left hand side. No, target is not in the range of this left part. So we need to move to the right hand side again, and now we'll come to the right hand side, and mid will come to the right hand side, and now we'll check if ARR of mid equal to target. Yes, it's now equal to target, and we'll simply return the position of the middle element, right? So now let's try to code this problem. Yeah, so we'll start with the simple binary search. Int low equal to 0 and int high equal to ARR of so let's rename this as ARR length minus 1, right? And now we'll start with the loop, which is low, while low less than equal to high. What we'll do now, we'll compute the middle index of the middle element, which will be going to be low plus high divided by 2. So middle is the middle element of the whole sub array, in the range of the low and high. And now we'll check if ARR of mid equal to target. If that's the case, we'll simply return mid and we need to do nothing else, right? If ARR of mid is not equal to target, we need to decide either to go to the left hand side or we need to go to the right hand side, right? And now to check, what we'll do is we'll check if the leftmost part of the middle element, if the corner element of the left subarray is smaller than the middle. If that's the case, then we can say that left part is sorted, and now we need to check in the left sorted part. If not, we need to go to the right hand side, because then the right hand will be sorted and we need to check in the sorted part. So that this means that we always need to search in the sorted part only, because we can't find element in a unsorted part, which we, right? So now what we'll do is we'll check if ARR of mid greater than equal to ARR of low, right? So if that's the case, we can say that left part is sorted, right? If this means that left part is sorted. And now we'll check if target is present in that range. So to check if target is present, we'll write like this: target greater than equal to ARR of low and target less than ARR of mid. So this condition will help us to know whether the target is present in that range. If that's the case, we'll move to the left hand side, which we'll do high equal to mid minus 1, because that means the element, if present, will be in the left hand side, right? If not, then we'll go to the right hand side. We'll simply do else low equal to low equal to mid plus 1, right? And now this part tells that the left side of this middle element is sorted, and if the right hand side is sorted, we need to do some more computations like this: else if target greater than ARR of mid and target less than equal to ARR of high. To see whether the element is present in this range or not, what we'll do is we'll simply do low equal to mid plus 1, else we'll do high equal to mid minus 1, right? And after coming through this loop, we'll simply return minus 1 if there is no element found. So let's try to run the code. Yeah, the output is correct. Let's compile for some other test cases. Let's check for 3. Yeah, so the output is correct. Now let's try to submit it. Yeah, so it worked fine, right? The time complexity of this solution will be big O of log n. So what we did in this question is we found the middle element and checked either the left part is sorted or the right part. So this else if condition is to check whether the left part is sorted, and if this else condition is to check whether the right hand is sorted. And either of those means if the left part is sorted, we now need to check the target element in the left sorted part, or we need to check in the right hand sorted path. So that's how we solve this problem. Thank you.